How to hack a boat? That's the question we actually asked ourselves a couple of months ago. And this special of Threat Talks is all about that. I'm here in the headquarters of Damen Shipyards in a virtual environment, a training facility where captains, actual maritime personnel is trained to tug a boat. We're virtually in the harbor of Rotterdam. And if you see me go back and forth a little bit anxious, that's because I don't see where we're going and I'm not really a very good captain. My name is Jan Koning. Let's get on to it. Welcome to Threat Talks. Let's delve deep into the dynamic world of cybersecurity. Let me first introduce my two guests of today. Luca Cipriano, he's a threat intel specialist at Ontoit, and his job in the last couple of months is to hack into an actual boat. Right, Luca?
Yes, indeed. And
on my other side, it's Jeroen Scheerder. He's a specialist in anything cybersecurity. He's very seasoned professional, and we don't have time to list all his capabilities today. Jeroen, welcome.
Thanks.
Gentlemen, I have to explain a little bit why we're here and what we're doing, because in 2 weeks from now, and we are a bit nervous about this, we are going to present at the One conference in The Hague about how to get into a boat, how to hack the OT and all that, right? And we're mid-journey there. And by the time we actually air this episode, 2 weeks ago, that already happened. So you can look it up online whether we actually succeeded today. But then we have cybersecurity professionals going to an actual shipbuilding company, Damen Shipyards, to make this happen. How did that go, gentlemen?
Luca? That was really, really fun. So we're a bit nervous because in this specific case, if something goes wrong, it means that for the boat, everything goes well. So we hope that something goes wrong because the actually boat need to tilt and we need to lose the cargo. And if it doesn't happen, then, well, for us, it went bad. So we hope that we're going to be able to make it. I think we had a lot of fun doing this, just creating the boat. We had to build a boat.
So what do you mean by a boat? I mean, we're here, not a virtual one like we're in right now.
No, so we build a boat. And since we're nerds, we actually wanted to buy a boat that's pretty much comparable to a real boat. In the sense that it's not just an object that floats, but it actually has a boat system similar to a system that you would find on a real vessel. So a system that is that has a control system that can be manipulated and so on. It has an onboard network and all these things, very realistic. So we mess with something that could have been a real boat.
Yeah,
the size is smaller, just for clarity.
Yeah, I mean, we're not building a real cargo ship container. So
at some point you ask for a swimming pool to test it. So and an actual boat doesn't fit in that. So it's how big is it?
It's about 2.5 meter, almost 3.
I think it's 3.5 meters.
Oh, 3.5.
So it's sort of
12 feet
canoe-sized, Canadian canoe.
2-person canoe. Yeah. So in the last 2 weeks we had to remove our IT hat and put like I don't know, for people that watch the Vikings, dressed like Floki, the boat builder.
Yes.
So we had to really be out of our comfort zone and do something that we are not used to it. We tried to look for somebody to sacrifice to Odin, but nobody volunteered at the office. So, well, we hope it's going to be all right anyway.
But we did have pliers and blowtorches, and it was fun.
Yeah, it was really fun.
And where are you now? Is the boat has been built?
Yes.
We have a boat.
We have a boat.
And it floats. And the boat actually has a ballast system. Because in real boats, of course, they get loaded with cargo.
Yeah, you say, of course, you're already a maritime expert almost.
I'm not. I'm pretty far from a maritime expert as you can get, I think.
But we
don't even have tattoos. So
well, I do, so I compensate for that.
Yeah, so we're a good team. We built the boat. It actually has this ballast system, which a ballast system balances the boat in rough winds and with shifting cargoes and these things. And it does so using ballast tanks, which use the one supply that is vastly available on a boat, which is water, to shift weight from between left and right.
So we also spoke with we're here at Damen. We spoke with actually engineer here, and I can tell that the model that we built is quite similar to how it really works a real boat. There are a few differences, like for example on a real ballast system they use a pressure sensor, of course, and they have a gyroscope. We didn't go so in depth like having a gyroscope and this kind of things, but we use sensors that can feel water in our ballast system. So it is quite realistic, and the actual components are the real components that are used. Like for example, a PLC is similar as the PLC that you will find on a boat. So
the real thing, yes.
The real thing.
Just for the record, if a boat does not have a ballast system, then it will be uncontrollable, or what happens?
There are boats that don't use ballast systems. I'm not an expert, as we spoke before, but they need some sort of other systems that keeps the balance, of course, because as you can imagine, the water moves, so it needs to float straight, and it needs to compensate.
The ballast system makes sure that it's level all the time.
It makes, yeah, indeed.
That's its intention.
Its intention. So there are compartments with water that fill and empty in order to keep the boat stable.
So it's intended to keep the boat level, and this leveling is performed by a process, a system. So there's a PLC, and the PLC engages drain and fill pumps, port and starboard and center, and it's under control of a system. So it can be manipulated.
Yeah, so for people that are not familiar with the terms, like PLC is a component from OT systems, which it is used to not transfer data with metadata, but to transfer commands and control industrial systems. So that's what we played with.
Yeah, so in your canoe-sized vessel, there's actual real-world equipment, OT equipment that you put in that's actually used on.
Yes, so a remote on-off button for an array of pumps.
If you're really wondering how this boat looks right now, we actually will put a picture of it in the show notes, so you can.
And it's beautiful.
Yes, it's beautiful.
Okay, so and then you want to do something with it. Be the hacker.
Yeah, sure. So first of all, we want to show, of course, that now IT and OT, they are merging together more and more. Before it was more separated, but nowadays it's, the line is it's subtle, so that they're merging, and you need to talk with each other because you have monitoring systems that need to read the readings and this kind of things. And OT systems are not secure by design, so there's no encryption, no verification of so as long as you are in the network and you send a command to the PLC, then the PLC will activate without checking who's sending the command and why. So that's quite easy once you're in the boat, once you have initial access to mess with the PLC.
As we talked about last week in our main episode, the access to this, it's not like boats are offline these days. So it's not like you need to be on the boat with your laptop as a hackerman and somehow do something with the ship you're on yourself. The whole point is you can get to it remotely. That's an assumption.
Yes, you can, and this really happens. For example, I think it was this week's news that a US Navy vessel, the crew actually stealthily installed a Starlink antenna and hooked it to the internal network on the system without the captain knowing it, because they wanted to watch Netflix while on mission. Yes, but that of course is a direct communication channel to the inside systems within a war vessel. So normal people think this is pretty serious stuff if it has ICBMs on board. Mm-hmm. Yeah. So this really happens, and you can get this access. Yeah. And these systems are exposed, and they're simple industrial systems that do not validate the parties issuing them commands.
Yeah, this we've seen it in the past with Stuxnet as well. Also, when it was more separated, there's always the possibility to craft a malware that infects a computer and acts after. So you can activate it by time or triggering something. So now it's just easier.
So you don't need to be on the boat. You just need to be able to control a system.
Yeah.
on the boat.
And whether that's a system that's installed by someone that shouldn't be there, like the Netflix example, there's also systems that monitor the ship in the first place that should be there by design, right? That you can also abuse.
Yes,
which can also be vulnerable, of course.
And we did not do this only for the one conference where we're gonna show the boat, but we actually organized and we created a couple of scenarios for a capture the flag. So we're gonna organize this also internally, where our colleagues can actually hack the boat, and we started thinking about what is a real scenario that this can happen. We're not give out too much information, of course, because we're gonna reuse it probably and organize it again. But we thought of ways where, like, for example, third parties need to check the monitoring system on a boat and how they would allow them to check some things while they do some works. And there are several ways to gain initial access.
You mentioned something very interesting. So can we open this to the audience at some point?
I would like to. I think it will be nice. Yes. Why not?
Subscribe to our channel, because we'll post an update for you, so you can then actually participate in this capture the flag. It would be really cool.
I mean, this is a rough first. So we're gonna do a run, but probably we will work on it and make it more complex with more ways to exploit.
How to build and sink a boat.
Yes, indeed. So it's gonna be fun.
So, and what kind of things did you? I mean, first the building process. I mean, before you can hack it, you need to have a boat. What kind of, as a non, hands-on guy? Well, you are obviously quite hands-on, but as an IT guy, what kind of difficulties did you figure out? I mean, you had to.
Well, we sniffed a lot of glue.
That's because we made a Ballast system with a PLC, and we had to glue it, and we had to first clean it with a PLC cleaner, which is funny smelling, and then the PLC.
So we designed a construction in which the ballast tanks were actually made from PVC pipes.
PVC, I said and PLC, but I meant PVC.
And we cut them to size, and this of course involves cutting and gluing and all these things. Just basic manual skills.
And actually, I went back in time as well, because for some things we had to do some soldering. I smell some of those fumes that was years that I didn't smell. It brought me back in time. So yeah, that was one challenge. All these works that we had to do.
Did it work the first time?
No. Of course, we used some components that got damaged in traffic, so we had to check the design and use a multimeter to check the internal diagrams and find where things were broken, and had to devise ways around. We rewired some stuff, and we skipped a few components, and we lengthened some wires.
Yeah, we had to adjust some things and fix.
And fix the power supply.
Fix the power supply, of course.
All these things. So that's just.
But we caused the shortage of electricity. Do you remember?
Yes. But that's just basic electronics hobby stuff. Yeah.
So we had some actually also fun. We discussed this also in the main episode, but we had this. We had almost a heart attack when. Do you remember when we saw like smoke coming from where we had the boat here, and we thought that.
Oh yes. Turned out there was an exercise.
Yes.
A disaster test.
So we were testing the boat here at Damen, and at a certain point while we're in the office, there's the fire alarms going off, and the smoke apparently was coming from where we left the boat. So we were like, what did we do? And of course here at Damen, they have like their own BFV, which is incident response, but they really have like fire department kind of, so they came all dressed with the smoke.
You're like, I was the cause of this. I hope we didn't bring too much damage.
Yeah, I hope it was not us.
Did we shut it off when we left? Yeah.
Yes, and apparently it was an exercise, luckily. Okay, it was a drill.
Yes, or we would have had to build the unsinkable too.
Yes, exactly. What happened to the one? Well, let's sink. Yeah.
All right, yeah. So there is a boat now. You managed to somehow get it there. It does capsize, right? If you fill with
So we have this control system on board, in which the pumps can be engaged, and they do fill the containers. So we can fill it in such a way that it tips over. I think
we can also
capsize it, but we can tilt it to such an extent. I think 25 degrees or something, which is really quite a tilt. And if you imagine large container vessels, of course, we see one in the background, containers are stacked very high on these systems. And if it tilts over a few degrees, then the containers will topple. Mm-hmm. So what we're going to do is to stack containers on the loading deck of our mini container vessel. And what we aim to show is that we will see the containers actually tumbling into the water.
Falling into the water. The reason
At
why...
the one conference, there is no swimming pool or anything.
Yeah, that's another challenge. We had to organize somebody to bring a swimming pool there. So
you're bringing a swimming pool to a cyber conference.
Yes, that was not up to us. Of course, we have marketing helped us, and they arranged a lot of things because, of course, as you can imagine, it's not like a two-man job.
There? How long does it take?
How much water? You did all the calculation. I was in the email. He's like great with mathematics, and every time he goes into deep mathematics, I'm like, yeah, I trust him. Sure, I'm just reading.
So I'm doing advanced stuff like multiplication to compute height and width and depth and so on. It'll take a couple of hours to fill.
Yeah, probably.
So some preparation is needed.
And what's the chance that it's actually going to work there on stage?
I would say slightly over 50%.
Oh. Yes, I mean, let's not jinx it, please. But the tests that we did, they worked. Let me knock on wood.
Guys, I'm presenting this thing. I'm presenting the keynote.
Right, yes. So if this were a horse race and we were a horse in this race and I were a betting person, I would bet on us.
Okay. That gives me a little comfort. Yeah. Okay. Yeah. Can we talk a little bit about the technical part of this? So we talked a little bit about getting the initial foothold through the Netflix system, through another IT-related system. Mm-hmm. Can you tell us a little bit more about that, or the next step that follow?
Yeah, sure. So, for example, if I was an attacker and I gain initial foothold, the first thing that you're going to start to do is reconnaissance. You're going to start to enumerate the hosts and the ports that are open. And of course, I don't think that many of the boat builders think about zero trust when they're building the internal network of a boat. So most of the boats have a flat network, so you can reach.
So let's one step back. Of course, we need to access that network. So how do we do that? Well, you inject a system that will be carried on board with malware. This is a common thing, right? Systems get compromised and there is a botnet software controlling these systems and they're on board. So we have access to the internal network.
Because you can send email to a ship.
Yes. The other thing is boats do have onboard Wi-Fi. So you can compromise the Wi-Fi using man-in-the-middle attacks and then derive the wireless key and you're on the ship. Sometimes boats even have a guest Wi-Fi, which is supposedly not connected, but sometimes has control systems, for example, to display information about the boat. So there is a system that is connected to this guest system that also reads internal systems. That system is an interesting target, of course.
You're giving away too many information for the ZTF.
Oh, okay. Yes. But I'm stopping. Yeah. I'm stopping there. So we have multiple scenarios in which we somehow get to access this entirely trusting network that contains the systems that control a PLC and that contains the PLC itself.
Yeah, so then you can send network packets to the PLC itself.
So
that's where
first of all, you need to find the PLC. Then you need to understand how the underlying software.
You can.
Yeah, you need to find also how the underlying software works. So you need to know which bytes and bits you need to manipulate in order to activate.
So find and fingerprint the PLC.
Also understand how the software works to activate and deactivate the pumps. But of course, we're seeing, especially when you have like APTs, so advanced attacker, that they do espionage.
But then you have a couple of virtual switches that you figure out. You can enable, disable pumps. You can valves that you close or open, that kind of thing. How do you know which one to do? I mean, if you want to
Yeah, that's what I mean. Like, okay, of course, in our scenario, without giving away too much information, there is a way to reverse engineer how the system works. I'm not going to explain too much, but like, for example, we have seen the US, for example, attributed cyber espionage to APT-40s, which is China Nexus, and they managed to infiltrate networks also of companies that were building boat and submarines, so you can have some sort of espionage before. So you have, for example, the specifics of how that model of ships is built and how the systems. So it's not like that a script kid is going to capsize a boat. That's not going to happen. So it requires knowledge and probably also preparation at the beginning. So there are more ways to understand.
Until it gets scripted, of course.
Yeah.
Cool. And that's not that far away, I think.
Yeah.
We could script it, couldn't we?
Yeah, we could, indeed.
Okay, so potentially within reach of a script kiddie. One more interesting thing, I think, that is not just controlling the system, but the system itself also is self-monitoring. So if you engage a pump, an alarm will sound in the cockpit, which needs to be acknowledged.
Right here.
Yes. But of course you can silence that alarm. So you can stealthily enable the pumps.
Because of course the alarm also is controlled by the PLC.
So this is also an interesting challenge in our capture the flag.
Yeah, and of course in a real world scenario you could eventually also overflow the ballast system, create damages to the boat, which we don't do, of course. We don't want the boat to explode or something, but there are several things that can happen.
One last topic. I know, and I'm sorry to spoil the fun you all have in making it all break down. What can we do against this?
Yes,
because now you know how to get in.
Yeah,
you're going to prove it to me in 2 weeks on stage.
Yeah, we're gonna show it. I would say for sure the first thing is like microsegmentation. So just create microsegments on the network that can't be reached. So
yeah, you mentioned a lot of lateral movement. Huh? You go from one system to the other, and if you apply zero trust and segment those networks and create barriers within the compartment of the ship, as they do with physical stuff. I mean, ships that they built here are unsinkable for a reason, because they.
Yeah, so you insert control boundaries where you can actually implement measures that govern the contact between these isolated segments. For example, if you have this PLC, of course it needs to be read by certain other systems, but these systems don't necessarily need to write stuff there. And those are different Modbus commands. Mm-hmm. So you can, for example, conceive of a network topology that allows a monitoring system to just read stuff from the PLC and not write to it. That would be a strong safeguard against a compromise through that monitoring system.
Sounds like a real zero trust least privilege.
I think zero trust rings a bell in this,
in this
sense. Yes.
Another way, of course, is like always patching systems on the boats to prevent
but how
vulnerabilities.
do you patch a PLC?
No, well, you can. You could patch a PLC because there are vulnerabilities on the PLC as well.
PLCs are
but I was
fully patched and not vulnerable?
I was talking more about, for example, the monitoring system that is a stepping stone to interact with the PLC. So monitoring. I don't want to give away again too many things for the
Let's not
capture the flag, but there might be like services running on that host that might run softwares that need patches. So that is something that you need to patch. But also one of the scenarios that we did is like, for example, if you find an unattended Ethernet plug on the boat itself, so physically enter and then you can just plug in, like you can implement some layer 2 protection. Like for example, you just...
you should assume that someone plugs something in, and if you don't have protection against that, then think again.
Yeah, if it's free, for example, just assign it to a black hole VLAN, like a parked VLAN or this kind of things.
Sounds a little like what you need to do in the office networks as well. It's similar.
Yeah, indeed.
Similar.
Indeed.
Yeah. Okay, gentlemen, I'm afraid this is all the time we have. I'm looking forward to the next to our presentation in 2 weeks, and let's see what we can present with the Capture the Flag. Thank you very much. Keep it up.
Thank you.
make it capsize, please.
Yeah. So let's hope it sing. It capsized.
One time. Yeah.
Yeah.
Viewers, thank you very much for tuning in. If you like this and want to see the next episode, because there's going to be more details on how to hack a boat, there's even more ways to do it than just go into the OT. Subscribe to this channel, because next week you will get the next episode, which we will also present from this venue right here. And also, please like us, because if you like us, we can actually spread the word much easier to others. And with that, I say goodbye to you here from the simulator at Damen Shipyards headquarters, and hope to see you next time. Thank you for listening to Threat Talks, a podcast by Onto It Cybersecurity and AMS-IX. Did you like what you heard? Do you want to learn more? Follow Threat Talks to stay up to date on the topic of cybersecurity.